For the next one, we're going to look at another wall question. In fact, we're doing walls for both of them. But we're going to handle when we've got algebraic distances. So let's give it a read and piece the diagram together. So a ladder AB of mass m and length 3a has one end resting on rough horizontal ground. Okay, so let's do something like this. Is it a peg or a wall? The other end rests against a smooth wall. Okay, we could jump straight in, couldn't we, with mg? We know that this is rough, so let's call this r, and let's call this mu r. And this is a smooth wall, so let's call this s. So 1, 2, 3, 4. That sort of looks about right. Anything else going on here? A load of mass 2m is fixed on the ladder at AC. So there's something else going down. The whole thing's 3a. This says AC, so it means it's about here somewhere. So 2m is the mass, so there's 2mg. Uniform, yeah, we did that in that diagram, uniform, 60 degrees. Okay, so I'm going to give you a neater version of the diagram, and the first thing we're going to do is we're going to find mu. Okay, so there we go. So they've done the distances and they've just got A written on them for now. So you may find that this is a bit intimidating at the start, but just watch out for later, because what will happen at some point is you will find that these will all just neatly cancel. Okay. And it doesn't matter whether you've written them like this or you have something in the same ratio. So what I mean by that is, well, if you just double all of these bits, for example, yeah, 2a, a, 3a. And in fact, even if you drop the a at the start, you'll notice that this will give you the same answer. So don't be too caught up by those bits there. With a wall question, the left equals right, the up equals down, all tends to work out quite nicely. So let's do that. I'm going to call this S again, and I'm going to call this mu R, just because of personal preference. So everything to the right is going to be mu R, and to the left is S. Everything up is going to be R, and then down is 2mg plus mg, so it's actually 3mg. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Great. Looks like I've handled all those forces there. Clockwise, anti-clockwise. So one thing to notice on this is that the way that you would handle this one is going to be the same as how you handle this one. So you'll find that your clockwise is easier to do them at the same time. So you're going to get one there and you're going to get one there. And maybe we can even jump to what that will be straight away based on knowing how these questions go. Yeah, so let's do this first one here. So that's going to be 2mg cos 60. And then it's a away. So it's going to be 2mg cos 60 times a. Okay, that's the first one. And then we're going to add to it the other one, which is going to be, well, this is going to be mg cos 60. And then it's a different distance, because you always do the distance from where you're taking moments. So it's that distance there that we're looking for, which is going to be 1.5a. All right, so that's your two clockwise moments that you're going to have. And then the anti-clockwise moments. So the anti-clockwise moment is sort of going to come, well, where did we draw on the previous video? I think we drew it like this, because it's just a little bit easier to think about. Maybe we'll do that in a different color. So we talked about this one here in the previous video. We said if that's 60, that will be 60 as well. This is opposite. So this will be S sine 60. So for the anti-clockwise moment, so for the anti-clockwise moment, it's going to be S sine 60. And then how far away is that? That's 3a away. So we're going to set those top two equal to this one underneath. And in fact, let's just tidy this up a bit. So I'm going to call that 2amg cos 60. And I'm going to call this, what's that? 1.5 at the moment. 1.5 amg cos 60. There's not too much tidying up with that. So let's just put everything together. So if we put this all together, so we get 3.5 amg cos 60, just checking my work, equals s sine, nope, let's do that as 3 as sine 60. Okay, so here's the bit where you're going to see something we just talked about earlier. So notice now that we could do a couple of things. So one, you've got a on both sides, so the a wasn't really important, it's just sort of a ratio between those. Notice that they've also both got 60 in there, so if you had to show that question, you could turn it into tan or cot if you needed to. We've also got these equations up here that kind of go into this as well. So what do they want? They want the coefficient of friction. So it's hard to fit all of this on one screen, but we'll have a go. Let's try writing it out now. So the coefficient of friction will be equal to S over R. Yeah, S over R. So the coefficient of friction, S. So let's try and get S on its own. So not the nicest numbers. I might just double them to start with. So 7 and 6. So let's do 7 over 6. So 7 over 6 mg. And then what would that be? It's cos over sine again, isn't it? So it's cot 60. So 7 over 6 cot 60. And I think in my working out, I've already worked out the value of cot 60. Yeah, because with all of these things, remember, like cot 60, what we could do here is we could have just so something to watch out for, yeah, is we could have turned this into a half, for example. That's a half on that one there, and sine 60, you could also write as root 3 over 2. Okay, so I think for the sake of my working out, I'm just going to leave it as cot 60, but in case you see lots of fractions, it's your exact values, that's what's going on. So let's just trace my steps back. So that was 7 over 6. I dealt with that bit there. The a's cancel, the mg was there, the cos had the sine over, yeah. So that bit there is the s, and then r is in fact just 3mg. So if you want to tidy this up just a little bit, the mg's will cancel, and you're going to get 7 over 18 cot 60. And if you work this one out, this should be apparently 0.225. Okay, so you could go into doing exact values, but do you see the steps? Again, left equals right, up equals down works quite nicely on a wall. I've done the moments, a little bit more going on here because there were 2 moments going clockwise in the same direction. The anti-clockwise moment was the same as in the previous video. I've rearranged to get mu on its own. I've written a fraction, and then we got the surprising result that lots of things cancel. Yeah, so the a's cancelled early on, the mg's cancelled a little bit at the end, and we're almost now done with the question. So find the coefficient of friction. We've done that. State how you've used the assumption that the ladder is uniform. That's a nice question. It just means that the weight acts at the center of the rod. In other words, 1.5a from the left or the right. Yeah, that was all we need to say for part B.